Stanford University.
Okay, well, welcome to Lecture 4 of CS193P, Stanford, winter of 2015. So I've been doing all demo up until now, and now we're going to be doing all slide today. So I have a lot of stuff to talk about. Most of this, although not all of it, is covered in your reading assignments, okay? But here I'm going to try and highlight the things that are pretty important and also show you some stuff that's just not in that reading assignment that you kind of need to know. So this is definitely not a substitute for the reading. You'll still need to do the reading in order to kind of get the details of a lot of this stuff. So, but this hopefully will kind of get you focused in on the key stuff. All right, so first I want to talk about optionals and enums. So now that you know what an enum is, I can tell you what an optional really is. Okay, an optional is just an enum. Okay, it's a very simple enum. It's a generic, kind of like array. You know how an array, you specify the type of thing in it. Optional is exactly the same. Okay, it's a generic. You specify the type of optional it is. And that type, which is T here in this little enum, is just the type of the associated value. You know that enums can have associated values. So that's just the type that if the optional is not nil, that's what you get. So that's all an enum is. And so, for example, this is what it would look like if we used the enum notation to do an optional. Saying, you know, x, which is an enum, or it is an optional string equals nil, would just be saying x equals optional angle bracket string dot none. Okay? Or if you're setting it to not be none, you would say optional angle bracket string dot sum, parentheses, the associated value, which would be hello. Does that make sense? So optional is really actually super simple. With the question mark and the exclamation point, I know that makes it seem like, whoa, it's really complicated, but it's pretty simple, really. It's just syntactic sugar to do this optional. Now, the unwrapping really just looks like this. It's just a switch. And in the case of sum, you give the value back. And in the case of none, you raise an exception. Okay? And simple as that. That's why it crashes when you unwrap something that's nil. Okay? So that's optional. All right, so array, I just want to, we covered this, so I'm going to go really fast through this, but arrays, the syntax there is the same, right? That square bracket thing, that means exactly the same thing. Also, you can't append or modify in any way an array that is a let, right? That's a constant array. I just want to make it clear that defining an array to be a constant by saying let something equal an array versus var something equal an array means that it's immutable. So you can't do append or insert or anything else that you could do on a mutable array. Also, of course, if you access an array with the square brackets and try to pull out something that's outside the bounds of the array, this array only has 4 animals in it and I'm trying to get animals 5, that's going to crash. Array index out of bounds, just like pretty much any language you've used. How to enumerate an array. If you wanted to go through every single item in an array and look at it, you can use for in. Okay, so you just say for some variable you want in your array, and then inside there, that'll be your value. Okay, pretty obvious. I put this here mostly to compare it to the next slide, which is dictionary. So dictionary, again, that square bracket thing is an alternate for the exact same thing. So if I had a nice dictionary here, I can create a dictionary using this square bracket notation, which is just square bracket, key colon value, comma, key colon value. Okay, you know that. And you also know that if I access a dictionary with the square brackets, it returns an optional. And that's because, for example, here, I'm looking up Pac-10 team Ohio State. Obviously, that is not a Pac-10 team, so it's not in the dictionary, so it's going to return nil. Okay, so that's why when you access a dictionary, it comes back, it's an optional. To enumerate a dictionary, you use a tuple. Okay, so you say for the tuple, key comma value, in the dictionary, and then inside there, key and value will both be set. Okay, so that's really easy way to enumerate dictionaries. Make sense? All right, I'm going to teach you about a new struct that you haven't seen called range. A range is just 2 points of a sensible type. So a starting point and an ending point is exactly what you would think a range would be. Now I say sensible type here because, you know, the sensible type depends on what you're talking about. For an array, the sensible type is an int, but for other things like a string, it's not, and we're going to talk about that in a minute. Range is also a generic, just like array or like that optional enum. And so it takes the type of thing. So the range, again, to specify a range in an array would be range angle bracket int, because ints are how you index an array. So if you were going to specify a range in an array, they would be ints, okay? And it's approximately what I put here. It's not exactly this, but as far as given what you know so far, this is the best I can describe it to you. It's just a struct that has a start index and an end index. And it is a struct. You can go and get those values and set those values out of there. So array's range would be array of int, range of int. String, you would think that a string would also be, subranges of strings would also be specified by an int, but it's not. There's a special type called string.index, which is an index into a string. I'm going to talk all about that in a later slide. Okay? So ranges, just like arrays and dictionaries, we don't usually say range angle bracket int equals something. We use this special syntax, and the special syntax is this 3 dots or 2 dots and a less than sign. Okay, so the 3 dots means a range from the first thing on the left of the dots to the other thing on the right of the dots. That's the start index and the end index, and it includes them both. Includes both the start and end. Whereas the other one, 2 dot dot less than, means it includes the first one, but it does not include the second one. So it's an open-ended range. Okay, because both of those kind of ranges are common. So that's how we specify a range. 99% of the time we don't use the range struct to do it, although you could create a range struct and you could pass it as an argument to anything that takes these dot dot dots. You could put an actual range in there as well. Okay, they're the same thing. It's just the dot dot dots are syntax to create that range for you. Okay, and the things on the either side of the dot dot dot, you know, it depends on what kind of range you're kind of creating. If you're creating an int range, a range of angle bracket int, then they'd be ints. Okay, but if you're doing a string, they have to be string.indexes. And that's a little harder to create because a string.index can't be created from a numeric literal. You have to create it programmatically. So we'll talk about that in about 10 slides or so. And you can enumerate a range using for in, just like we can with arrays and dictionaries there. Okay. All right, other classes besides arrays, dictionaries, range. NSObject. So NSObject was the base class for all Objective-C classes. In Swift, we don't really have a base class for all Swift classes. However, there are some kind of advanced features in iOS that require even your Swift class to inherit from NSObject. I can't really talk about them because there's other things you need to know for me to even explain them to you, but down the road that will happen. It really doesn't hurt to make your Swift class be a subclass of NSObject, so we could have made calculator brain be a subclass of NSObject. It wouldn't have hurt, and in the future, once we learn these advanced things, it'd be nice to be able to do those advanced features with calculator brain. So it's kind of one, you can feel free. I'm not sure what to say the best practice here is to always have your Swift classes inherit from NSObject. All the classes in iOS, like UI View Controller and all those, they all inherit from NSObject eventually. It's the superclass of all of them. There's not really much in NSObject anymore that matters. But like I say, there's these advanced features. But then there's NSNumber. You've actually briefly seen NSNumber. NSNumber is just a generic number holding class. It just holds a number. That's all it does. And it has a ton of methods on it. I'm not going to go through them here. You can look in the documentation. But the methods are things like double value, int value, which is give me your value of yourself as an int, as a double, etc. In Swift, we don't really use this very much because it's strongly typed, and so we're using types like int and double. But in Objective-C APIs, there's NSNumbers lying around. And so you kind of need to know about it. I'm going to talk a little bit later about the fact that all those Swift types are kind of magically bridged to NSNumber, okay, those ints and doubles. So you really don't even have to worry about NSNumber unless you're going to use something like the NSNumber formatter that we used in the assignment, okay, because that thing returns an NSNumber. Yeah.
So if there's Swift, is there a way to make like an array that holds any kind of...
Yeah, so the question is, if there's no NS objects, well, it wouldn't really matter about NS object, but the question is, can I create an array where there are random objects in there? And we're going to talk about that later. Now the class NSDate, exactly what it sounds like, stores a date, lets you get the current date and time too. Pretty self-explanatory, has lots and lots of methods in it. And it has even more and more methods because there's those three other classes mentioned here, calendar, date formatter, and date components. And if you're ever doing a date where you're going to put a date on screen as part of your application, you really want to look at all these classes and read the documentation that talks about dates, because dates are displayed very differently around the world. Different calendars, different, even different languages. The order of the month, day, year, even if you're using the Gregorian calendar, is different. So you really, dates are tricky to get right if you want to build an app that can work around the world. Okay, so I'm just kind of warning you, if you're going to build an app like that someday, you want to really understand date and all its friends here. There's NSData, super easy class. It's just a bag of bits. Okay, could be a gigantic bag of bits, small bag of bits, whatever, but it's just untyped data that's just in there. You can think of it almost like a pointer to memory, and you just don't know what's in there. This is how iOS will pass around untyped data, raw data. It passes it around using this class. It'll be obvious when we start using this what it's for. You're not going to be using NSData much in this class because we're not dealing with raw data that much. Okay. All right, so I just wanted to mention some of those classes just so you know they exist. You can check out the documentation on all of them to find out more about it. And I'm going to revisit a few of them like array and dictionary and string because they're so important. I'm going to actually talk about some of their methods. But I want to talk a little bit about data structures in Swift in general. Okay? There's really three fundamental building blocks for your data structures that you might build, and you've seen them, two of the three of them in detail, but they are class, struct, and enum. Okay, they're the three basic building blocks. And they look very similar. Their declaration syntax looks very similar, right? Just the only difference is whether it's class, struct, or enum, but otherwise looks the same. They're also very similar in that they can all have properties and functions. Okay, all three of them. Now enums, their properties can't store any values. You store the values in an enum in that associated information, but they can have computed properties. Okay, and all three of them can have functions. Right? Okay, so it's important to understand. So they're very similar in that way. They're also similar, at least structs and classes, in that they can have initializers. And we're going to talk about initializers in detail in a few slides. Okay, so they're similar in a lot of ways, but there's a couple ways in which they're very different. All right, classes are the only ones where you have inheritance. Okay, and it's pretty obvious. That's kind of the main definer of what a class is. It has inheritance. And then introspection and casting, which I'm also going to talk about a little later, those are only for classes. So none of this casting thing I'm going to talk about can you do for structs. And the most important difference to understand, and we really went over this in the demo, is this value type versus reference type. Structs and enums are passed around and stored in variables, copied, okay? And classes are reference types. In other words, we pass around pointers to them. They live in the heap. And remember that classes, their memory in the heap is managed for us. Okay, so there's nothing, we don't have to do anything, alloc and free them. We create them when we want, and when no one's using it, it gets cleaned up. And it's not garbage collection, okay? Reference counting, automatic reference counting. But I want to just have a slide on this value type versus reference type again, because it's a really important thing to understand it, because people get confused writing the code and they don't really understand what's going on. But a value type, structs and enums mean that it's copied when you pass it into a function. It's copied when you assign it to a different variable. This one especially gets people, they don't understand this. If I have, let x equals array, and I say let y equal x, that makes essentially a copy of x. Now, that copy might be lazy behind the scenes, but as far as you're concerned, it's a copy. Okay? And if you want it to be mutable, you could copy it into a var instead of a let, and now you could mutate it. And if you mutate it, you're mutating your own copy. You're not mutating what the other one pointed to. Okay? Because of this, when you make a struct or an enum and you add a function to it that modifies it, you have to mark it with this keyword mutating. And that's so that Swift knows when someone else tries to use your enum or struct, if they use one of these mutating functions, it obviously has to be in a var, not in a let type variable. Okay. So reference stored in the heap, reference counted. Even if you have a constant pointer to a class, let something equals the class, you can still send messages to that thing that can mutate it because it's in the heap. All right, so you have a pointer to it. So, and when you pass it to a function, you're passing a pointer to that thing. So if the function modifies it, it's modifying the thing back where it was called. Okay, so which do you use between these two? Well, 90% of the time you're going to use a class. This is object-oriented programming language. You're going to want to have the ability to do inheritance and overriding and things like that. Structs are really more for the basic fundamental types like double, int, array, dictionary, string. These are all, really fundamental things. And when we get into the graphics, you're going to see that points, sizes, rectangles, those are structs, okay? But most of everything else we build with classes, okay? And since it manages all the memory for you and all that, it's really no big pain to use classes. All right, so methods. So I want to talk a little bit about methods, all right? You obviously, if you override a method in a class, you have to put the keyword override in front of it, okay? You can also mark a method final. That means no one can override it. So if someone subclasses a class you wrote, they can't override it if you marked it final. You can also mark an entire class final, which means it's, this is the end of the line. You can't do any subclasses of it, basically, okay? Both types and instances have methods and properties. So a type is like array, that's the type. An instance of an array is an actual array with things in it, okay? Let's look at this piece of code right here. I've defined a double, okay, this var, which is a double. And I say if the double is sign minus, that means if it's minus sign, it's negative, then I'm going to set the double to be the absolute value of the double. So is sign minus is an instance variable, an instance property. You send it to a particular double to ask it, is your sign minus? Whereas double.abs is a type function on double. You pass the double you want to operate on to it, and it works on it. But you're not sending abs to a particular double. You're sending it to the class, or the struct in this case, the type. You see what I mean? So some methods you send to instances, particular instances of something. Some things you can send to the type, all right? So two different kinds of method. But otherwise, the rules for them are about the same. It's just that who you ask to do the work. You declare a type method or property by using static in front of it. So like abs, there would be static func abs takes a double, returns a double. And that makes it so that you send it to the double type instead of sending it to a particular double. In a class, you use the word class, not static, okay, because it's called a class function. Okay? So I just don't want you to be confused when you start seeing methods like abs that are sent to the double type. That looks kind of weird, but it's perfectly normal. Okay? And what would you do with a type? When do you have a type function versus an instance function? Well, if you're doing any kind of utility work, right? You're not doing anything particular to a certain kind of double, but you're just doing utilities. You would have those in there. Sometimes you would have type methods that create objects of certain kinds and hand them out. Maybe a shared object, like if you had only one instance of an object for your entire app of a certain type, maybe you would ask that type, give me that shared instance. Okay? So it's kind of for utilities and creation, that kind of thing. I don't want to say they're rare, they're not super common. You'll see them in iOS, and you'll probably use them occasionally. You would use them really instead of global functions. You can have global functions in Swift, of course, but you'd really probably prefer to make it a type method so that that function is associated with, the type and kind of, unless it truly is a global function that just applies to the world, it's not about a particular class. Usually you would make them be a type function or a type variable. All right. So method. Now let's talk about the parameter names of methods. This is going to be the crash course. You read all about this, I hope, in the documentation. But all parameters to functions have an internal name and an external name. So we're talking about the parameters, okay? So down there, foo, the parameters, parameter to foo there. Okay, it has internal name and external name. So the internal name, which goes kind of near the colon, is the name that that thing is going to have as a local variable inside the method. That's its internal name. And then the external name is the name that callers are going to use to put before the colon, okay, when they call the thing. So in bar there, I'm calling things, and in foo, I'm defining them. So you see that here, I call foo with external colon 123, even though internal to foo, that thing is called internal. Okay? So you can have both external and internal names. They can be different. You can put an underbar. Remember, underbar is kind of the don't care thing in Swift. You can put an underbar if you don't want callers to use an external name. So now look at bar. It calls foo. It doesn't even put internal colon or external colon. It just puts the argument there. Okay? So the underbar says, I don't want to have an external name for this. Okay? Now, that is the default for the first argument to a function. So foo only has one argument, so its first argument, its only argument. You can see that when you call it from bar, you don't say internal colon. That's because that underbar thing is the default. Now, if you don't want that to be the default, you can force the first one to be required by putting a pound sign there, a little hashtag. Okay? And that makes it so you have to say internal colon. Okay? For other parameters, not the first parameter, but other parameters, the name, the internal or an external name, is mandatory, okay? Unless you put and you can change the name. It can be, you can have the external name be different for any parameter, not just the first one. And you can put the underbar in there and make it so even the second one has no parameter name. This would be incredibly un-Swift-like to do this, to have a function like this that takes two arguments and the second one doesn't really have a name. Because in Swift, you can kind of think of the name of the method as describing what the first argument is. The first argument to your method should always be kind of obvious based on the name of the method, because the method does something, it operates on something or whatever. That should be the first argument. That's why it usually doesn't need a first parameter name. And then all the other arguments, you want to give them names so people understand what they are, okay, what they're about. And in other language, a lot of times you'll have a really long method that says, you know, do this and that with this other thing and that. And then in parentheses, you have 4 arguments. And people have to kind of match up what's what. Here, the name of the method really is kind of distributed out amongst its arguments. So it's really a lot easier to read and a lot easier to understand what the heck is going on. So I don't recommend it. I don't recommend putting the underbar in parameters. There are some exceptions, but I generally don't recommend that. Okay. All right. Properties. Let's talk a bit about properties. So property observers are very important, and we're going to use them a lot. They are very simple. You have a property, like here I have some stored property. It's an int equals 42. And yes, I didn't need the type there. I'm just putting there. Okay, and throughout all my slides, by the way, green, I put things in green because I'm just trying to make you draw attention to the fact that this is code. Okay, that's all green means. But yellow usually will mean this is the thing I'm talking about right now. This is the thing to pay attention to. So you can almost think yellow is like highlighted, okay? So here I have some stored property. It stores an int, 42. And notice though, even though it's a stored property, not computed, it's stored, I still put a curly brace after it. But in that curly brace, instead of saying get and set like a computer property, I say will set and did set. Okay? So these are little pieces of code inside the will set and did set. They get called when that property gets set by anybody. So it's called a property observer because I'm observing, with this code, I'm observing this thing is being set. And the will set is called right before the property's value gets set, and the did set right after. And inside the will set, you've got this special variable called new value, which is going to be the new value that's going to be set. And then inside did set, you've got this special thing called old value, which is the old value. Okay? Now, you use this in really kind of these two cases. One is you have a stored property in yourself, in your class, and whenever someone sets it, you want to kind of notice and do something. Okay? And the other one is you inherit some property, and you don't necessarily do anything with that property directly, but you want to know when that gets changed by anybody. Okay?